A company like Pinterest has millions of transactional emails to send to people. The scalability challenges of sending high volumes of email means that it makes more sense for most companies to use an email as a service product rather than building their own. Chris McFadden is the VP of Engineering and Cloud Operations at SparkPost, and he joins the show today to explain the architecture of SparkPost's email as a service product. SparkPost started as an on-premise email technology company for large enterprises and has since evolved into a SaaS product. In 2014, the company migrated to the cloud, which has changed its infrastructure as well as its operational model. Full disclosure, SparkPost is a sponsor of Software Engineering Daily. I hope you enjoy this episode. Life is too short to have a job that you don't enjoy. If you don't like your job, go to hired.com/sedaily. Hired makes finding a new job enjoyable, and Hired will connect you with a talent advocate that will walk you through the process of finding a better job. It's like a personal concierge for finding a job. Maybe you want more flexible hours or more money or remote work. Maybe you want to work at Facebook or Uber or Stripe or some of the other top companies that are desperately looking for engineers on Hired. You deserve a job that you enjoy because you're someone who spends their spare time listening to a software engineering podcast. Clearly, you're passionate about software, so it's definitely possible to find a job that you enjoy. Check out hired.com/sedaily to get a special offer for Software Engineering Daily listeners. A $1,000 signing bonus from Hired when you find that great job that gives you respect and salary that you deserve as a great engineer. I love Hired because it puts more power in the hands of engineers. Go to hired.com/sedaily to get advantage of that special offer. And thanks to Hired for being a continued longtime sponsor of Software Engineering Daily. Chris McFadden is the VP of Engineering and Cloud Operations at SparkPost. Chris, welcome to Software Engineering Daily.
Great. Thanks, Jeff. Glad to be here.
You work at SparkPost, which is an email delivery service. What does that mean?
So what that means is we help companies deliver email to their customers. So a lot of companies, they need to send everything from purchase requests, forgot passwords, bank statements, all of those kinds of things that need to be delivered, as well as even marketing email as well. So we really provide a platform to deliver a very large chunk of the world's email, particularly legitimate email, both in our cloud service as well as we have on-premise offerings that people run.
Now, if I'm running a company like Twitter, what kinds of scalability problems would I encounter if I were to try to stand up my own transactional email service? Yeah,
and certainly we have a lot of customers that use our on-premise product that do stand up their own, but it's a very challenging endeavor to do that. So you need to purchase a lot of servers, you need to purchase the software, and then you need operations staff to be able to run that. You also need deliverability and compliance experts to be able to manage your email infrastructure. There's also security concerns and things like that as well. From a scalability perspective, you need to be able to ramp up based on the bursting requirements you have. So it can be difficult to add additional servers very quickly, especially if you have bursty traffic. Unlike some web applications, email servers are very stateful. So you have a lot of data that's on the server, and adding new servers need to be coordinated with the rest of the cluster. So that can be a challenge if you are on premise, is being able to manage, especially the elasticity needs of your demands.
You mentioned the term deliverability. What does that term mean?
Yeah, so delivery and deliverability, that is in some ways the most challenging part of email. So, you can it's very easy to send an email, but the challenging part is actually getting the inbox provider, such as Gmail, to actually accept the email, and then also getting it into the user's inbox. one of the challenges that we have in this industry is that most email out there really is spam or phishing. So with the inbox providers such as Gmail, they'll assume that most email is spam. So you have to know all of the techniques and the idiosyncrasies of email to be able to get it delivered. So that comes down to proper configuration of your security settings, properly warming up your IP addresses that you're using to send, following best practices around handling spam complaints and bounces and unsubscribes. So if you don't follow those practices, your email will get blocked or will certainly go into the junk mail folder. So that's sort of the whole, beside the technical part, there's really all this extra stuff that goes on top of it to be able to get the email into the inbox. And that's deliverability.
In order to give people who are unfamiliar with the technical depth of how much complexity there is in an email going from point A to point B, could you give, in whatever depth of explanation you want to go into, given a contrast of what happens when I send just my own a single email on Gmail or some other email service versus what happens when I send an email using a delivery service and I'm sending a large mass of transactional emails throughout the day.
Yeah, so Gmail, as well as say Hotmail and Yahoo and AOL, those are really they provide an inbox, like an email service for people, for really doing person-to-person communication. So you write up an email and you send it to somebody, and Gmail will handle a lot of the details of ensuring that it gets where it needs to go. But when you're dealing with the companies that we provide a service to, it's really machine generated emails. So transactional emails are coming, say, from an e-commerce system, or from maybe it's a marketing front end that's generating these. And so when you're sending that mass volume of email, that is where the inbox providers like Gmail are much more suspect of those. They're not coming from a person; they're really coming from a company, and there's a lot more suspect activity that goes on there, and so it's a lot harder to deliver a large volume of that kind of email at scale. Again, sort of person-to-person communication, that's a lot easier, I think, for the inbox providers like Gmail to provide that service. But you wouldn't be able to use that same service to, again, send your password resets or to send your marketing emails.
What are some of the layers of infrastructure or different types of providers that sit in between me at my, sitting at my inbox service like Gmail, or if I'm making a request to a Spark Post server or some other email service? What are some of the layers of infrastructure that email, that message is going to pass through before it potentially makes it to the other person's inbox?
So, for example, if you're sending from our service to Gmail, the email certainly will go over a number of different intermediaries in the internet. But what you would want to do, certainly to ensure that your email is secure, is within the email we use what's called TLS, which is very similar to what you might use on the web. If you're shopping, everything will be secured through SSL or HTTPS. So that can certainly be one way you can just guarantee that where that the email is secure going from your delivery service through to the end recipient. The rest of the infrastructure, the email is a very old service and is very distributed, so it leverages a lot of the just the basic infrastructure of the internet, and I think that's one reason why it's so ubiquitous and and continues to grow in popularity. So
Spark Post as a email delivery service, it expresses an API, or it reveals an API to developers who want to interact with email in an automated fashion. What are the ways that a developer typically wants to interact with an API for an email? Like if I'm a developer, what are the different conditions where I'm going to want to send an email, and what are the kinds of configuration points of the API that I'm going to want to mess with?
Yeah, so we provide both a REST API as well as SMTP. So I'd say maybe about 50% of developers will simply just integrate with us through SMTP. And that's a very well-known API. We provide a way to be able to pass control information through special headers. But I think the interesting area where there's a lot more flexibility is using the REST API. A primary API endpoint that customers will use is the transmissions API. And what that allows you to do is pass in a content, like a template, essentially, and which is HTML, but you have the ability then to then provide a list of recipients and then fill in the template, not just mail merge, but to be able to even do like a shopping cart and other things like that within the email and dynamically generate your email. Other things that you would want to do through there is you can provide additional meta information like campaign ID or other tracking data. That way you can get that back through reporting and analytics, tie that back into your own system to understand, whether somebody actually got the email, whether they opened it, or clicked on certain links, and be able to then improve your overall program and effectiveness.
One thing I've always heard about developer APIs is that they can be tricky to build because you have to avoid ever making breaking changes when you update the API because, if you were to break somebody's now deprecated API that they may have built on, then they're going to start to get bugs and they're not going to know where this is coming from. How do you think about evolving the developer API over time?
So when we decided to launch SparkPost a few years ago, we spent a lot of time thinking about how we wanted to do the API in a way that was a modern API that would be flexible for us to iterate on. We did settle on using the REST approach, which one of the foundational parts of that is you have resource endpoints, and then the data format is JSON. There's a couple advantages of doing that in that we can not break the API, but continue to iterate and improve on it. We can add additional elements into the JSON bodies and responses. We can add additional parameters as needed, and we can also add additional endpoints. So it's been possible for us to continue to have V1 of our API without introducing any breaking changes. And we've continued to develop, additional features and capabilities, new endpoints, as well as new features and capabilities of existing endpoints. So that's something that we take very seriously. We have a governance group that monitors that stuff. We just as a principle across the board, we don't do those kinds of breaking changes. And I think the mechanism using REST, I think, really helps with that.
It's always interesting to me to talk to people who are building services for developers because it's a much different customer base than if you're building a software product for marketers or for retail people, because you have a technical customer and you can ask them technical questions or they will give you technical feedback for things that they want in the service. What is the relationship like between SparkPost, the company, and the developers that you work with? Or the developers that are consuming the API, I should say.
Yes, right. So our customer base is developers, both from startup, all the way up to larger enterprises as well. So that developer audience, we do have to work with them in both marketing as well as supporting them in a different way than we might with a different kind of customer base. So developers, they really appreciate good technical content and tools. So we provide things like client libraries and migration guides and how-tos so they can very easily understand the service and get up and running. Even the whole onboarding process has to be very simple. That's one reason why we do a freemium model as well, so that they don't have to put in a credit card or pay for anything. They can try it out. They can use it. They can even use it for extended period of times for sending 100,000 emails a month for free. So that's important because of, again, that developer audience. We also have a Slack channel. So developers can join the Slack channel and talk to our developer relations group, as well as even our support team and our deliverability team. So being able to get, that kind of interaction, I think is important to developers. Some, they certainly can submit support tickets, but being able to actually just have a chat and ask, how do I use this PHP client library, and getting that quick feedback, can be very helpful for them. So, we do continue to try to nurture this developer community and really listen to them. And it's important also to be able to, when they provide feedback, that we actually act on that and, deliver improvements and features based on that feedback.
When I'm choosing the tools for my side projects, the first thing that I look for is ease of use. That's why I love MongoDB. It is the most popular non-relational database, and it is super easy to use. At the beginning of a project, I often don't know the shape of my objects, and Mongo makes it easy to evolve the database schema as I like over time. Over time, as my project gets popular, I'm going to need to scale, and thankfully, MongoDB has built-in horizontal scalability, but configuration and database maintenance aren't really what I want to spend my time on. Thankfully, MongoDB Atlas was released in 2016. MongoDB Atlas is the easiest way to get access to MongoDB without having to run the database yourself. You pay only for what you use, from small projects all the way up to large production deployments. To try MongoDB Atlas today, go to mongodb.com/sedaily and get a free $25 in credit. Use promo code GOATLAS25 to get that $25 in free credit. Atlas is the only hosted MongoDB service built by the engineers behind the database, the company MongoDB. With Atlas, you get end-to-end encryption, you get VPC peering, you get access to the latest releases, and for a limited time, you can go to mongodb.com/sedaily, enter promo code GOATLAS25, and get that $25 in credit and get started with MongoDB Atlas. Thanks to MongoDB for being a new sponsor of Software Engineering Daily, and thanks for being the database behind a lot of my favorite side projects in the past. We're really happy to have MongoDB as a new sponsor of Software Engineering Daily. The company has been around for 15 years, providing various email services. Although I imagine that the things that people have needed out of an email as a service have changed over time. How has that business evolved?
So we have been doing this a long time, and up until a few years ago, we were focused 100% in developing and delivering on-premise software. So we have two on-premise products, Momentum and PowerMTA, and they are very popular for on-premise. And we used to, be the mindset, we would do a release or two every year, and that seemed to work well. When people are running their own infrastructure, they don't really look to upgrade very frequently or make major changes on a regular basis. But there really is a increasing trend to move more things to the cloud. And so our own customer base, as well as looking out in the market, people are looking to not have to run all that infrastructure themselves, because it is complicated, and not just the servers and the software, but all the human elements of being able to run that properly. So that's why we moved to the cloud. And now at this point, most of our focus, has been providing this cloud service. And it's great because we can iterate very quickly, and rather than once, a couple times a year doing releases, we're doing releases, deploying new software several times a week. And that way customers can get that, get those improvements very quickly. And I think that's just a trend across the industry now, is people looking to focus more on their core business and use more cloud services for things that are easily accessible.
Give me an overview of the SparkPost infrastructure as it looks today.
So the core engine for SparkPost is Momentum, and that's the same MTA that we sell to a lot of our larger on-premise customers. Momentum is a very powerful and very fast system that occupies again, kind of a core part of our whole infrastructure. Beyond that, most of our infrastructure is based on microservices. So a lot of Node.js code, some different data pipelining processes for metrics and reporting. And then our front end is a client-side JavaScript app. So that uses the same APIs that our customers use. We also have a lot of tooling around compliance and deliverability. So understanding, who's who's maybe a bad sender that we need to be able to suspend or terminate, and then ensuring that our deliverability, is as optimal as possible. That requires a lot of automation as well. And the actual infrastructure we have, to be able to scale the way we need to scale, it's all, again, the nice thing about Amazon, it's all virtual. So we can, treat that infrastructure as code and, automate a lot of that.
Were there any adaptations that you had to make to allow the originally on-premise software to be deployable for the cloud, the elastic model that you have for a lot of your customers today?
Yes, it was a bit of a challenge. Initially, when we first started in the cloud, it was much more of a momentum in the cloud or a managed cloud approach, where we took the on-premise software as is and installed it, in the cloud. And it worked very much the same way. But that was a couple years ago. And so since then, we've moved to more of this, continuous delivery model and more elastic, based, scaling. So, the main MTA, Momentum, it's a very mature and complicated piece of software, mostly written in C. And, so to be able to take that where we were doing very infrequent releases and being able to deploy that several times a week really required a different mindset in how we did it. So we had to add a lot of additional automation, a lot of additional automated tests in particular, and really automate end-to-end the whole test and deployment of the platform. We had to rethink the entire configuration of the system. We had to rethink how we scale up and how we scale down. And it's certainly has been a bit of a journey. I don't think we're 100% where we want to be, but it's been a little bit simpler for some of our other microservices and such, which are kind of more natively amenable to that, to what we want to do in the cloud. But for Momentum, which is a very large system, it would be akin to trying to, automatically deploy a database and auto scale a database. It's that kind of complexity.
It was interesting because it sounds like the way that it worked out is you have this monolith that customers have been deploying on-premise for many years, and then when you decided to turn it into a cloud service, you had to put some tooling around it. You also built a bunch of microservices around it, and that seems like the way that you're building out from here on out, but it seems like you still kind of have this core monolith that you work around, that you deploy to the cloud. Or is that accurate, or are you trying to break down the monolith? What's the thought there?
So the Momentum part of this, the MTA, it's really responsible for doing the email delivery. And so as such, that's kind of an important part of the whole service. It does also have APIs built into it. So we use that for things like generating messages, and, so instead of also submitting messages through SMTP, you can do it through REST. But that is still a core part of the engine and needs to be very scalable. And so that kind of proven technology, which is used, at some of the largest senders in the world, has been very beneficial to us. So, there are some things we've had to do to make that easier to deploy. And that includes, again, rethinking how we configure it and how we operate it. But it is a really solid piece of technology. So, the things that we have been building around it are everything from, users and accounts and reporting and analytics and some of the management components, self-service aspects of that. They don't really belong or need to be part of that, kind of core MTA. So I wouldn't say so much that it's a monolith. It's more, that's a really big part of the service. A lot of the other services are much smaller, compared to sort of this main engine. But Yeah, it's still sort of a service-oriented microservices approach, but there's sort of an outsized member of that whole group, which is Momentum.
Now, what kinds of testing did you have to write for it to get it in a situation where you could have that continuous deployment model that you're talking about?
So we already had a really solid set of unit and integration tests for the platform, for Momentum. Where we needed to do more was through our deployment pipeline. We have additional functional tests that are automated and smoke tests. So when we kind of roll it through, we have a sort of an integration environment that it gets auto deployed to, and then we have a staging and production environments, and we have automated smoke and rollback for that. So when we do the deployment, it will actually do kind of a rolling upgrade validation of each, taking things out of sort of out of circulation in the cloud, in the cluster, upgrading, doing some verification tests, adding it back in, and in that sense, if there's some failure, it will automatically roll back. So we've had very good success with that, and it's it's always sort of, again, there's always room for improvement. Looking at better ways to leverage things like Amazon Machine Images to do upgrades. Looking at how we can do more like blue-green type upgrades as well. So there's definitely a lot of room for improvement, and we continue to kind of look at our options there and iterate on that.
Interesting. So the current process for doing a deployment, is it a gradual deployment? Like, do you deploy 5% of you deploy a change to like 5% of your servers and then gradually roll it out to more servers, or how does a deployment work for a new piece of software?
Yeah, so so each of the different microservices and services are deployed independently of each other, and each of them has a slightly nuanced method of doing that. In most cases, we do a rolling upgrade across the different services and do verifications and validations before kind of moving on to the rest. So we have, and we also have enterprise customers where we have a slightly different cycle in terms of when we upgrade them. We're looking at probably, I'd say our end goal would be doing more of a kind of a blue-green type of upgrade, actually standing up an entirely different cluster and then switching over. Just the challenge when you go back to something like Momentum, which is the MTA tier, that has so much state associated with it. So, it's not as simple as some web applications where they're completely stateless, and it's very easy to do that. We have to kind of look at, how those systems are operating in a stateful way. They're managing messages that are on their actual spools that they're trying to deliver. And so there's just some challenges, I think, that are very different than maybe a traditional web application deployment.
When I think about a service like SparkPost that sends email, it makes me wonder how much you actually have to store, like how much is persisted. So if you're processing a ton of transactional emails every day for a social network like Twitter or Pinterest, how much data do you have to actually store about those emails? Or do you have to store the email itself, or is it all metadata?
Yeah, there's really two parts of that. There's the message itself. So as the message comes in, it gets persisted to disk, and then it stays on disk until it gets delivered. So in many cases, that can take a second or less. But in other situations, there may be reasons why it's not delivered immediately. Perhaps there's a huge amount of mail that needs to go out right at the same time, and so if you're trying to deliver to, maybe Gmail's not going to have an issue, but maybe there's other smaller providers which will not accept all your mail instantaneously, so that will stay in basically an active queue. And then you may also have situations where the ISP is temporarily not going to accept your mail for different reasons. And so that will go into a delay queue. And that could, in some cases, things may be in a delay queue for hours or for days. And it may depend on the sender, and it may depend on on the receiver. But that's the messages. And so generally speaking, you're talking about maximum staying there, who knows, a day or something like that. But yes, there's a tremendous amount of metadata about the messages. And so, we take all that metadata and we store that, for both reporting purposes. So you really want to understand, how your campaigns or your messages are being delivered, how they're being engaged with. So we also track, for example, open and click tracking. And then we also have even more detailed metadata about the messages, and we make that available through webhooks, and then also an API where you can basically download this raw, almost like log data. It has a lot more detailed information. And so companies really need and want that real-time metadata that comes back from webhooks, because they need to know, for example, did you get your message? Did you click on it? Did you engage on it? And that often will feed back into a customer's own analytics systems and their own CRM systems.
What databases do you use?
So we use a mix of databases for I guess you'd say operational use. We actually have Cassandra, and that's nice because it's a clustered multi-master type of database. We also are using more AWS databases now. We've started using more DynamoDB, as well as Cloud Search, which is like a search service you can pair up with DynamoDB. We also use Vertica, which is a relational columnar analytics database. That's been pretty amazing for us because you're able to take raw data and feed it in there, and then be able to do real-time ad hoc queries against the database. So we've been able to provide a lot of our dashboarding and APIs for reporting, based on that data. We also use some other databases for different purposes. Like we use RDS, like Amazon's RDS for some things. We use it really depends. But I'd say our main databases are Cassandra, DynamoDB, Vertica for the most part.
Interesting. Do you have a internal way of deciding what database you use for a given service? Do you have like a sort of freedom to pick whatever database you want if you're in charge of a service?
So for operational uses, we started off with Cassandra, and that was in many respects because we were using that. We were actually at the time shipping it with our on-premise offering. And so that was something that could be easily bundled up as, in almost like an OEM approach. But as we're doing more things in the cloud, we're finding it's easier and better to use DynamoDB. So it's really NoSQL databases for most things from an operational perspective. No database really provides like all of the features and scalability that you need. So sometimes you need to use kind of a mixed approach or hybrid approach. So that's why we're doing more things now with DynamoDB and Cloud Search. So you can store your reference data, like system of record, in DynamoDB, but then have ad hoc query capability using Cloud Search. But any analytics, really looking at using, Vertica, looking potentially using Redshift, eventually. There's also a lot of other great analytics tools available from Amazon that we're using. So it does depend on the situation, but I'd say 90% of the time there's some sort of existing, pattern use case that we can borrow.
Let's talk more about scalability challenges. We talked a little bit about this earlier in terms of why a company would choose to go with a email as a service company rather than standing up their own transactional email service. But why don't you talk about how you have solved those challenges at SparkPost, how you've solved some of the scalability challenges of transactional email, or how some of those continue today and you continue to solve them, and what you're working on? Sure.
So we certainly, I think for a very large company that runs their own transactional email service and has a lot of their own expertise and such, maybe there's some sort of, economy of scale there that makes sense. For us, I think the real attractiveness is for many companies, both small and medium and even large companies where they don't have that expertise. They don't want to really develop that expertise, and they don't want to have to manage all that infrastructure. It allows us, since we have been doing this for a long time and we have a lot of expertise, we have the core software, which is Momentum, which is, extremely good at what it does. That really is one of the keys to our scalability, is having some of the best tools for doing that. Again, you think sometimes emails can be very easy. You send an email, how hard can it be to get there? But doing it at scale does require having really good technology. But then we also have, the people services. We've got a deliverability team. We have technical account managers. We've got a compliance team. And so we can make that available to our customers and provide the service at more at scale. And we continue to build and learn from the use of our customers. So we have what we call adaptive delivery network, where we look at things like codes that are returned by all the different ISPs, and we're able to categorize them across all of our customers to provide more meaningful bounce code information. And that kind of stuff is just very hard to do if you're trying to do it on your own.
Many of the shows that I have hosted have been about web applications, and SparkPost is kind of different in that it's, of course, there's a web application involved, but there's also a lot of back-end infrastructure. It's almost more of an infrastructure company, it feels like. So are the solutions to the scalability challenges of a highly available transactional email service, are they the same types of solutions you would have to scaling a highly available web application, or are there some distinct differences that come to mind?
So there are certainly many similarities. There are definitely some differences. So where the similarities are is much of the infrastructure that we have around the actual MTA is just plain old, web applications. And there's going to be a lot of similarities in terms of how we scale that stuff and manage high availability. Where things have become, most challenging for us or for anybody who's trying to do this with email is that there are some things that are not, that don't really translate to the web application world. As an example, the IP that you use to send email is reputation based. So there's a certain characteristic about it and permanence. So as you use an IP address to send email, it gains reputation over time. And so you can't simply, just add new IP addresses all of a sudden or remove that IP address. So there's some permanence to that. So as you're managing your high availability of your MTAs, you need to think about, how you handle your outbound IPs. So we've separated out sort of the main message processing with the actual external IPs that we send. So there's like a separate proxy tier to be able to handle that separation. So we can add more and more MTAs without needing to add more IP addresses. So you can have 10 MTAs all sending through the same IP address. So that's just one example where things are a little different in email world. There's also some inherently challenging issues with like SMTPs, like a very chatty protocol. And so trying to make sure you can optimize that. You're also dealing with, most of our traffic is really inbound. So people are sending stuff to us rather than, even like a streaming service or another web application where somebody makes a request and you deliver content to them. Our customers are sending a bunch of content to us. And we're also, bursting out email, out over the internet. And that's again, a very different sort of networking problem than most web applications would have.
Speaking of that burstiness, so the load is fairly bursty, or is there a steadiness throughout the day? And how do you set up your infrastructure to handle that specific traffic pattern?
So it really depends on the customers, so some customers are very bursty and some are not. And the overall pattern generally is very busy in the morning, in the US. So there's about 6 hours that are most busy. And I think that is when a lot of, more of the marketing emails go out. So throughout the day, we'll have a lot of transactional emails, but people will then also send their marketing campaigns in the morning. Most people tend to open their emails, when they get into work and they're looking at their emails, and they'll check it. Maybe they won't check it again until later that evening. So we do have another peak later in the evening when people are maybe on social media or checking their email, and so that could be busy from a transactional and from a marketing campaign perspective. So for us, it's looking at being able to dynamically add more capacity particularly to the MTA tier. That's very important to us, and continuing to fine tune that process to be more predictive. That's a constant kind of journey for us to make that better and better.
So, what is how do you allocate load between customers? So is there like a mapping of one server to a specific customer, or do you just like allocate, do you just predict load, or maybe you could just tell me how you balance load between servers and map those to customers?
So we have our more public cloud offering is much more of a shared infrastructure. So there is no specific mapping of customers to particular servers.
Oh, okay. Sure.
So it's a fully shared infrastructure. We do have some enterprise customers, which are much larger, and there's more thought that goes into sort of how they're being leveraged. It's not necessarily always the same way, but we have some customers that are sending billions of messages a month. So it's so those require a little bit more thought and are not necessarily on the same shared infrastructure. But most other customers, like smaller customers, they're dealing with even millions a day, and that can be kind of peanuts for us, as far as mail volume. So we've even had customers ask us, it's like, I want to send 100,000 emails in an hour. Is that going to be a problem for you? And it's like come on, that's nothing. So but we do have some customers that do have very large volumes where they're extremely bursty, and we do have to handle them a little differently. I don't necessarily want to get into all the details. Some of that may change over time too. So but we do have SLAs for our enterprise customers, and so how we provide, make sure that we're providing, quality of service for them is extremely important to us.
So you've got a bacon delivery service, and you need to notify your customers when their bacon has arrived at their doorstep. Twilio helps you make sure your customers get the bacon while it's hot. Twilio's programmable API lets you build SMS or voice alerts easily in the programming language of your choice, all in under 5 minutes with only a few lines of code. Now your customers get a text or a call the instant their bacon is ready. If your customers want to see the bacon frying on a hot pan, Twilio has video APIs and SDKs for the platforms that you know and love. Learn more at go.twilio.com/podcast and get an additional $10 when you sign up and upgrade your account. That's go.twilio.com/podcast. You will only pay for what you use, and it costs less than a penny to send a text. Get started at go.twilio.com/podcast. Get your bacon delivery service cooking with Twilio's APIs for voice, SMS, and video. So one problem that often presents challenges in a distributed system is the idea of exactly once processing, and email is something where at the highest level you really want it to only be processed once. You don't want your email messages to be sent twice. You obviously don't want them to be sent 0 times. Have you have you looked at this problem, or how do you guarantee exactly once processing in the SparkPost email system?
Yeah, so that is a core tenet, of the actual Momentum platform that we use. That's been tried and true for many years now. But the basic premise for it is the protocol. So when you're doing a REST call to the transmissions API, when you get back at 200, it's been committed to disk, for lack of a better word. So it's been written to spool and it's there. So when you get that back, you are, you know that it's been received. And then we have it, again, persisted to disk, and the queuing technology and Momentum is able to handle ensuring that it actually gets delivered. On the ISP side, once we get back a 250 OK, then we know it's been delivered. So there is the protocols in there actually help ensure at least once delivery. Now, is there a situation, where, for example, you make an API call and something goes haywire, you don't get the response back, or there's something that happens there, then certainly we encourage our customers in that situation that if you want to ensure at least once delivery, you should retry. You can also check things like webhooks to confirm, okay, did that actually get through for sure? And if I don't have confirmation did it actually went through, I could retry in that situation. But those are pretty rare edge cases. So email, I think, is much simpler in the sense that the protocols are really built in to be able to support that. But we have other areas where, like for data processing and such, where it's where we've had to think through that. So, as an example, we use SQS for sending event data through the system and being able to process that asynchronously. And we've had to deal with some challenges around queuing there to, again, this isn't messages, this is more like that metadata. And so we leverage things like Redis to be able to keep track of, whether things were already processed or not, and handle that. So there's definitely mechanisms for dealing with that. But it really depends. Like for messaging, it's really important that we have, deliver at least once and make sure it's very rare that there's a delivery that happens twice. But, and then on data processing, we just follow some slightly different but similar methods to kind of keep track to make sure that we don't process data twice.
I want to zoom out and talk a little bit more about the move to the cloud. It's easy, doing the show. It's easy to get the picture that everybody has moved to the cloud or everybody is moving to the cloud. But there are obviously lots of companies out there that are still thinking about, should they move to the cloud? How should they move to the cloud? And you've written about this some. So can you talk about the strategy that you had for moving to the cloud and how that is going today, like how you've updated the strategy, how you're thinking about it, maybe the costs and benefits of that for SparkPost?
Yeah, certainly. So, our heritage is as an enterprise, on-premise software company. And so everything about that was very different than what we're doing now. We had very long product development lifecycle. We also had a very long sales cycles. So on-premise software sales cycles are, you're dealing with, sometimes a year sales cycle. It can be very, very long. And there's a huge amount of, risk for the company. They have to do this huge investment. They've probably evaluated all these different options. It's a big deal to make, a big investment and to be able to, build out the infrastructure, the expertise, or do a huge upgrade. So, even marketing to, we often would sell into some of the technical organizations, but we're also, trying to sell into marketing organizations as well, into this at the CMO level, besides just the CTO level. What we heard from our customers, is that, they are more interested in, not doing all this investment in their own infrastructure, and they would be very interested in cloud services. So it was an important strategic decision for us as a company to then say, okay, if we're going to provide our service rather than just installed software as an actual service, how are we going to do this? At the time, maybe if we decided to do this 5 years earlier, we would have made some different decisions, but certainly the natural choice was to not build out our own data center, to use something like Amazon Web Services. And at that point, Amazon, and even now, is really the leader in that space. So it was a very good and safe choice at the time, and has proven out to be a very to have been a good choice. So that allowed us to move fairly quickly, and in the course of a few months to actually provide what initially was more what we called Momentum Managed Cloud. So we provided a very basic Momentum service in the cloud. And then a few months later, we offered a beta of our SparkPost public offering, which was, you sign up for free and use it. And then we went GA a few months later. So this is all within a year from deciding to do this to actually going to GA with our public offering that had, again, a lot of the additional capabilities that was needed for a cloud offering. We signed up some major companies like Pinterest and Zillow fairly early on, and were able to prove to them that we were much more effective than whoever they had been previously using. And again, we weren't novices at this space, and using something like Amazon Web Services, where it's all software based and virtualized, allowed us to really leverage our strengths there and not get too preoccupied, in, again, trying to build out some massive data center that would have taken a year, just to get all sorted out. We were able to really go from 0 to GA, all within less than a year. So that's also meant changes in how we do product development. We're much more iterative now. We have a general roadmap, but we're really looking at, doing smaller things like an MVP type approach, getting feedback, making more frequent deployments and releases. And then our sales approach has been completely different too. So we have a lot more inside sales reps who are selling, smaller deals for shorter terms. Customers are much faster. The sales cycle itself is much faster. People love being able to just try out the service for free. And then, if they like it, they can sign up with a credit card, or they can, move on to something like our enterprise offering and such. But the sales cycle, again, is just hugely different than trying to do on-premise software sales.
It's interesting that the sales cycle mirrors the iteration cycle in terms of how it's gotten shorter.
Yeah, because if you think about it, if you don't mind, it's the ease of adoption is so much easier in the cloud, and there's very little investment needed by the customer to try it out. So it's just very different from that perspective.
So when you are moving to the cloud, or when you were moving to the cloud, you looked at Netflix as a model for how they moved to the cloud. Netflix seems to adopt the higher level AWS services pretty aggressively. They are very open to saying they're all in on AWS. Other companies are more deliberate about what services they build off of from Amazon. Maybe they only use EC2 and S3. They try to avoid services that don't have some similar service on another platform like Google. It sounds like you are using things like RDS that might potentially have more lock-in. How do you decide what services to take advantage of?
I mean, the core of what everything's built on is on EC2. And Momentum, which is really where most of our intellectual property is something that we own that, and we build that, and we even ship it on premise too. So that is a huge aspect of it. And so we don't rely on Amazon for any of the email delivery. But where we look at things that can help us move faster, and using more of the managed services. So we have, using something like DynamoDB compared to Cassandra, trying to manage our own Cassandra cluster and, the actual time and energy that goes into that, versus something like DynamoDB. There is some real benefits, but I don't think that, using DynamoDB, you would necessarily get completely locked in. It would be certainly reasonable to be able to transition, back to Cassandra or to some other NoSQL database that would be offered, say, by Google or by Azure. So we're deliberate, and we do take note of those things. I think that some sort of auxiliary services and microservices and such that may leverage more of the Amazon technology, such as even now we're looking at how we can leverage some of the Lambda serverless technology that they have. That's when you're doing it at a microservice level, it can be fairly easy then to be able to replace things at a microservice basis. So I think if everything is one big monolith and you're tied in very tightly with all these underlying Amazon services, that could be challenging. But we're doing it more we are doing it very deliberately. So using a RDS versus some other relational database, it's fairly easy to swap out relational databases, quite honestly. So we don't really see that kind of thing as being a lock-in.
Okay. So you mentioned serverless. I would love to hear about some of the considerations you have. Like, what are the services that look promising for? So people who don't know, Lambda is this thing that Amazon introduced recently. Other companies have similar offerings, but it's basically like you can put in a line of code that you want to execute at a certain time, but you don't know what server it's going to execute on. That's why it's called serverless. But the cost savings are quite tremendous for serverless. So I'd love to hear about how you're thinking about using Lambda.
Yeah, so where we initially got introduced to Lambda was as a way to synchronize data between DynamoDB and Cloud Search. So one of the ways that Lambda has been described for DynamoDB is almost a way to do stored procedures. So if you're running Postgres, or Oracle, you can write all these stored procedures, but the challenge is that you're using the database as essentially an application server, and that can be very limiting from a scalability perspective. With Lambda, you can have triggers on the data, and the job, it's really a task, will get executed externally to the database. And so you can do things like synchronize, DynamoDB with a search service. And, that's a very natural way of using it. But we're also looking, we have a hackathon coming up this week, tomorrow and Friday. And I know one person's looking at how we can use Lambda to implement, say, our click tracking. Now, this is, again, more of a hackathon project, but it's kind of interesting to say, that would be very easy to do as a kind of task-oriented approach where it's very scalable. So as many tasks as come along, you can offload them to Lambda, and if the task is fairly simple, you don't necessarily have to have them think of it from a server perspective and then being able to scale up the server. Basically, let Amazon, continue to just take these tasks and execute them in their Lambda environment. So those kind of tasks are very attractive to do using Lambda. Any data processing has a lot of advantages to look at using Lambda. So I think it's from that perspective, the scalability, that could be interesting.
So just to wrap up, I know we're up against time. Since you work at an email delivery service, I'm just curious about what your perspective is on how email volume is changing. Do you feel like, is email going up? Is it decreasing? Is it staying the same? And, how are the demands on the inbox services changing? I mean, do they have to be more, is Gmail getting more scrutinizing of email and potentially marking more transactional emails as spam because they want people to have the same ultimate volume at their inbox? And just give me a picture for how the email volume world is changing.
Email volume is definitely going up, and all of our customers, their volume is going up in part because they themselves are growing, but also they are using email more. But I think that people are using email differently. So email is this Swiss Army knife of communication. So there's you can do interpersonal communication, but you can also send attachments, or you can send photos, and you can send legal documents. But there's all these other better ways that have come out for doing that. And so I think you'll see, email being used less and less, obviously, to share photos. Like there's other ways to do that, or sharing documents, or even, just chatting with friends. That's been replaced by a lot of social media or Dropbox or things like that. But actually, certainly, business to customer communication it continues to be the most effective way, as well as the most ubiquitous way that everybody has an email address, everybody can be contacted. They may or may not have different mobile apps, but they will have email, and just continues to show that even from a marketing perspective, email continues to be the most effective and most in terms of ROI, the best bet. So I don't think email volumes is going to continue to go up, but I think that you also see spam volumes continue to go up. So as you were alluding to, inbox providers like Gmail and such continue to get more and more aggressive and also smarter to be able to weed out spam and phishing versus good email as well. And I think that there are certainly a number of large email senders that help to continue to push standards around security and around good sending practices. And there's certainly some bodies, standards bodies and such out there, of which some of which we're a member of, to continue to help improve, make sure that email is the email that people get in their inbox is something that that they want to get, that they've signed up for, that they expect, and it's not some junk or some email from the famous Nigerian prince.
Right. All right. Well, Chris, thanks for coming on to Software Engineering Daily. It's been great talking to you about email and the infrastructure for delivering email that you've built at SparkPost.
Yeah, thanks for having me. It was a really good conversation.
Software Engineering Daily is having our first ever meetup in San Francisco, January 11th at Galvanize. If you live in the Bay Area and you listen to Software Engineering Daily, please come check it out. I would love to meet you. We're going to have some awesome speakers. We have Pete Hunt, who is one of the early members of the React.js team, who is now the CEO of Smite. Hasib Qureshi, who has been one of the most popular guests on Software Engineering Daily. Preeti Kasireddy, who has written about her career transition from venture capital to software engineering via Coding Bootcamp. Each one of these speakers is going to give an awesome talk, and I hope you can make it January 11th at Galvanize in San Francisco. You can sign up on meetup.com. You can also find the link on the Software Engineering Daily website, softwareengineeringdaily.com. I really hope to see you there.